We are doing right triangle trigonometry today, so we are thinking about SOHCAHTOA, sine equals opposite over hypotenuse, that's the SOH. Cosine equals adjacent over hypotenuse, that's the AH. And tangent is opposite over adjacent, that's the OA. What we're going to set up in this first part is trig ratios, which is just basically what are the numbers that go with it. So, for example, this is theta right here. If I'm doing sine of theta, that's opposite over hypotenuse, Hannah. What is the opposite side going to be? 21. It is opposite because it's across from the angle that we're looking for. What is the hypotenuse going to be? 29. Why is that the hypotenuse? It's across from the right angle. That's 29. So sine of theta is 21 over 29. If they ask for the trig ratio, that's what they're asking for. It doesn't tell you a lot, but it'll allow you to solve from there on. If I'm doing cosine here, Mara, I'm doing adjacent over hypotenuse. What's that going to look like? 20 over 29. What does adjacent mean? It's next to. This is the angle. This is next to. That's the hypotenuse. So although it's next to it, I don't count that. It's the hypotenuse. We label that first. And then tangent here. Grant, what's tangent going to be? 21 over 20. The opposite over the adjacent. Everybody good with that? Do it on the next one. Here we go. Courtney, what did you do for sine? 28 over 35. The opposite, because it's across from it, the hypotenuse is 35. Cool. Cosine here. Audrey H., what did you say for cosine? 21 over 35. That's adjacent over hypotenuse. And then we're going to do tangent. If we're doing tangent, Allison, what's tangent going to be? Opposite over adjacent. That would be 28 over 21. Everybody good with trig ratios? Let's solve for a missing piece. So number one, I got this guy right here. In order to solve a triangle, you need to know three things. And so in this case, we've got 18, we've got 55, and we've got a right angle. Okay, the right angle allows us to use SOHCAHTOA. If it weren't a right triangle, I can't use SOHCAHTOA. But because it is, that's why I'm using it. Okay, I'm using the two that I know then to find the missing one. And so which trig function here, Campbell, would you use to help us to solve for x? Sine. So what's 18 going to be? It's the hypotenuse. How is the x related to the 55? It's the adjacent side. So if we're doing hypotenuse and adjacent here, Reagan, which trig function are we using? Cosine. So cosine of my angle is going to be equal to what then? X over 18. And if I want to solve for x, what would I need to do, Garrett? Multiply by 18, multiply by 18. That cancels. In my calculator, what do I got to make sure I do before I use my calculator today? I'm in degrees now because I'm back in to PreCalc. 18, cosine of 55. I hit enter. My answer is 10.324. This is a little bit annoying, but this is kind of our rules in pre-calculus for rounding. For pre-calculus rounding, if we're talking about triangles and it's a side length, we're going to round it to 2 decimals. If it's an angle, we're going to go to 1 decimal. Okay? It's kind of arbitrary. It doesn't have a lot of meaning. We probably should just go for 3 for everything because that's what we do in calculus, but that's what we're going to do. So side length is 2, so this is going to be 10.32. Everybody good there? Let's do one more of those together. We got this thing over here. This is my angle right here. So compared to that angle, Alyssa, what's that 16 going to be? That's the opposite. What about the 15? Adjacent. So we've got 3 things, 16, 15 in the right angle. We're trying to find theta. And so we've got 16 and 15 opposite and adjacent. Audrey Gordon, which trig function are we going to use then? Tangent of theta equals the opposite over adjacent. What can I do here to get theta by itself? I want to get rid of tangent. I'm doing inverse tangent on both sides. That's going to cancel. In my calculator, I'm going inverse tangent, so second tangent, 16 over 15, and hit enter. I get 46. It's an angle, so I'm going 1 decimal, 46.8 degrees. Questions with those two? Try the next 2. I'm going to walk around and check on you because I don't know how good you are or not. I set up the basics here. Sine of 67. That's this angle right here. I did sine because that's the opposite and that's the hypotenuse. A little bit funky here, but not awful, hopefully. If I wanted to solve that, I don't know. Who have I not called on? Cole, what would you do here to solve this?
To solve it, I would multiply by x.
Yep, get x out of the denominator, so multiply by x, and then what would you have to do?
And then I would do sine 67 and then divide 24 by it.
Flip that, right? 24 divided by sine of 67. Yeah, same thing, yeah. Divided by sine of 67. Basically, these two things are going to switch spots. So in my calculator, I'm taking 24 divided by sine of 67. I hit enter. Boom, my answer is 26.07. Over here, I've got, this is the hypotenuse. This is the adjacent because it's right next to it. Yep.
Can you just divide by 24 in the beginning? Because, like, I know that gives you the right answer, but, like, what is it?
Because x is in the bottom, you'd have to take the reciprocal of that. So if you divided by 24, if you did sine of 67 divided by 24, then that is equal to 1 over x. And so then I would have to take the reciprocal of that, and it would get me my 26.07. Does that make sense? All right. So just multiply by x and then divide by the other. Cosine of y is equal to the adjacent over the hypotenuse. I've got that thing right there. Brett, what would I do to solve that? Inverse cosine of 18 over 20. So in my calculator, I'm going second cosine 18 over 20. Type it in, hit enter. I get 25.84. Or 25.8. It's an angle, sorry. Everybody good? Flip it over. On the back side, not adding a lot to it. We're just going to the next step. One thing you need to be careful with, or not careful with, just know that when we label triangles, labels do matter. You want to make sure you have stuff in the right spots. And so probably in regular geometry classes, you would deal with A, B, and C as your side lengths. We'll often talk about A, B, and C. The side lengths, normally the angles that go across from them match it. And so if one side is A, the opposite angle would be alpha. Or I'm sorry, would be capital A if you were in a basic geometry class. We're going to use the grown-up letter and use alpha. Okay, the angle that is across from B we're going to call beta. The angle across from C is gamma. It looks like a Y. Depends on the font. It changes a little bit, but that's our basic look. Everybody understand what that looks like? Normally we don't really refer to gamma as the right angle, because if we talk about a right angle, we just call it the right angle. But if we had C over here, it's going to be across from gamma. Make sense? Down below, they give you some basic information. It is your job to draw the triangle, label stuff, and then solve it. We are assuming that these are right triangles, so I'm going to draw the most basic right triangle ever. And then I'm going to label some stuff. Do that and solve it. You're trying to solve for A, C, and alpha in the end. See if you can do those three things. All right, let's label some stuff. Mara, which side did you call B? It doesn't matter, so pick one. That one. So if that's B, you said that was 5. Which angle is it, the top or the bottom? The bottom right angle needs to be 20 degrees. So if that's B and that's beta, that means this has to be A, that has to be alpha, that has to be C because it's the hypotenuse. Okay, so once I've done that, I'm going to start solving for stuff. Garrett, what did you solve for first? Alpha. How did you solve for alpha? Yep. All angles add up to 180. So however you got that, this is 90. And so these two need to add up to 90. It's 70 degrees. Cool. We've got that. Zach, what'd you do next? Sine of 20 equals 5 over C. So here's 20 degrees. He wants sine, so that's opposite over hypotenuse. So that is 5 over C. What would you do here to solve that thing? Switch the two, so C is equal to 5 over sine of 20. We do that. What did I just say? 5 divided by sine of 20. 5 divided by sine 20. Type that in, hit enter. I get 14.62. That is C. Cool. What else do I need to do here to find A? Cole, what else could I do here to find A?
To find A,
You could do Pythagorean theorem because I've got two sides, so I'm going to do the third. The only problem with doing Pythagorean theorem here is if you screwed up C, then you're going to automatically screw up A. And so I'd rather pick the ones I already know, but it's up to you. Yes, sir?
Are we just assuming we're working with right triangle?
Yes, I stated that beforehand. Yep. No, you're good. I stated it was a right triangle at the beginning. I should put that in the directions. I apologize. And so I could do, I've got 20 and the 5. I want to find A. And so I could also do tangent of 20 equals the opposite over the adjacent. So again, in my calculator, I'm taking 5 divided by tangent of 20. Type it in, hit enter, 13.74. Show me with your fingers. 0 is bad, 5 is great. Where are you on solving that triangle? Everybody, please. Okay. Make sure you ask questions as we go. We'll continue to go through it. It's just a matter of labeling and getting some reps at it. All right, cool. Angle of elevation. We're working on story problems. If I'm saying something is the angle of elevation, what does angle of elevation mean to us? All right, here we go. So we just described the angle of elevation is the angle from the ground up. That's it. Don't get overly complicated. That is not the answer you'll get in the back of the book, but I never give that answer anyways. A ship offshore from a vertical cliff is known to be 100 feet in height. It takes a siding at the top of the cliff. If the angle of elevation is found to be 25 degrees, how far offshore is the ship? So the hardest thing in this chapter would be drawing pictures given a story problem. You got to put yourself into the problem. The kids that miss these the most are unwilling to draw cool pictures, okay? Math is boring at times. Draw a fun picture and put fun things in it, and it'll at least make you smile for a half a second, okay? So take a second, draw that picture, label it, and make it fun, please. Okay. All right, yeah. Drawing the picture is way more important than actually solving it. Gracie, what's something I can label about this situation that's happening here? Yeah, the cliff is 100 feet tall. That's pretty obvious in the problem. If anyone didn't think that, they're ridiculous. 100 feet tall in height. Yep, we can label that. Audrey Harrison, what else did you label?
I labeled the angle.
Yep, angle of elevation. So which angle was that?
By the little person.
By the little person. See, it's so much easier when you have a cool picture drawn. 25 degrees, so we can call that 25 degrees down there. That's the angle of elevation from the ground level up. That's 25 degrees. Campbell, what else did you label here? 90-degree angle, absolutely. Anytime we talk about height, that's going to be a 90-degree angle, so we can put a height right there. And then the last thing we're looking for is how far offshore the ship is. So what thing am I looking for in the end? What line? The bottom line. Unless you have a magical ship that floats through the air to the top of the cliff, we want to know this guy down here. You can call it A. I'm going to call it X. It doesn't matter. I'm looking for that thing right there. If I want to solve this thing, Alyssa, I got to know 3 things. I know this 25 degrees. I know this 100. I'm looking for that X. Which trig function are you using to solve that? Tangent. Because tangent of the angle is equal to the opposite over the hypotenuse. If we're solving that thing, Courtney, what am I going to do? Multiply x on the other side, and then what?
Then divide tangent.
100 divided by tangent at 25. Good. So in her calculator, she is taking 100 divided by tangent at 25. I type it in. I hit enter. 214.45. That is x. Make sense on that one?
Will you be labeling units during story problems?
I mean, yeah, that's never a bad thing to label units. It's in feed.
No, I just want that's like gonna be required with that.
I mean, yeah, it's required. Yeah, it's required. If I was a good teacher, then yes, it would be necessary. So no, not necessary at all. So try the next one. Ladder's leaning against a building. It seems like just yesterday we were calculating how fast that ladder was falling, but now we're just calculating the actual stagnant ladder. It was literally yesterday. Now all we have to do is break out a tape measure, and we could solve our problem. Before we had to be way fancier than that. See what you can do. There are two parts to that one. Look, Grant, what's something you labeled here?
I labeled the base of the triangle X.
Base of the triangle X. Cool, because eventually I want to know the distance, the edge of the ladder to the base of the building. What's something else you labeled in this problem? Brett, what's something else you labeled? Angle of elevation. Which is the angle of elevation? The bottom right angle. That's the angle of elevation. What do you label it as? As Y or theta. Let's call it theta, but yeah, you can call it whatever you want. I'm just going to call it theta just to make things easier on myself. That's theta. Amanda, what else?
The ladder is 20 feet.
Ladder's 20 feet. This is 20 feet. And base of the window is 18 feet, so we can label that as well if we'd like. That's 18 feet. Everybody go with that? Then we're going to solve it. Cole, what'd you do to solve for something?
First I did the Pythagorean theorem.
Pythagorean theorem. You picked the easy one. So what's that going to look like?
20 squared minus 18 squared.
20 squared equals 18 squared plus x squared. So he subtracted the 18 squared and square rooted it. X squared is equal to the square root of 76. X is going to be equal to 8.72. Super. Then we're going to solve for the other part. If I'm solving for the other part here, Mara, what'd you do for that?
I did sine of theta equals 18 over 20.
Sine of theta equals 18 over 20. This is opposite of that. That's the hypotenuse. Opposite over hypotenuse. What'd you do then to get theta by itself?
Inverse sine.
Inverse sine. That goes away. In my calculator, second sine, 18 over 20. Hit enter. 64.2 degrees. Questions on right triangle trig? There's nothing super fancy. Once you've done it a few times, you should be good at it. All right.